In this video, we'll talk about another type of functional form misspecification that we can test for, which is, classified under testing for or testing against non-nested alternatives. So let's try to think about what this means. So typically, you would encounter situations where you want to figure out whether an independent variable should appear in level form or log form, right? So level form would just mean that if you have, let's say, salary data in dollars, right, you're just incorporating salary in dollars or in thousands of dollars in your regression. And that's just the level form of it. But the log form is just going to be when we take log of salary, right? So we want to see whether we want to incorporate salary or log salary in our regression, or any other variable for that matter. Okay, so that's the idea here. So we can basically consider two models. One in which the explanatory variables appear in level. So this is in level, and the test is going to be against this other regression, which is looking at the x's in log form. Okay, now the problem with this is that these are non-nested models, right? This model, let's call this 2 is not nested in 1, so it's non-nested in that sense, right? So we can't use an f-test for this, just like we did previously. We can't do that. So we have to use different approaches to decide what we need to do. This is not to say that we're testing necessarily this model 1 against 2. It could be 2 against 1, right? So just remember that it also applies the other way around. So there are two approaches to do this. The first one was given by Mizon and Richard in 1986, where basically you regress y on x1, x2, also on log of x1 and log of x2, okay? And so to test the significance of the variables appearing in levels, right, we can just test whether gamma 1 and gamma 2 are jointly equal to 0, and that's an f-test, okay? And to test the significance for logs, we can test if gamma 3 and gamma 4 are jointly equal to 0, right? So that's how you go about it. And if, let's say, if you were testing for this, for example, and your f-test is significant, then you would basically infer from this that keeping of these variables in log form is important. Okay, so logs become important in the functional form in how they're introduced. The second approach was given by Davidson and McKinnon in 1981. And they said basically that let's first estimate the model with log terms only and get fitted values, okay, of the y caret. Okay, so this is that caret here. Oops. Okay, so we're basically estimating this this model with log terms only, right? So in this model, we're not going to estimate anything in level form. So take these two out, right? And you just regress y on log of x1 and log of x2 and maybe other log variables, and you get the fitted value, which we're calling y caret. And then you're going to regress y on on x1, and x2, and there should be a plus sign here. This is a typo in my notes, which I will fix. Oops. Plus theta 1 times y caret. So let me write this out so it's clear. This is what we're doing. Okay, so we're gonna run a regression of this on this, right? Y on all these variables. And then we're gonna basically check for the t statistic on that y caret, basically. For that theta 1, is that significant or not? And if it is significant, then we reject the model in levels, and then we can do the opposite as well, which your book talks about, to test if levels are significant, okay? In which case, basically, you're going to be running a regression of y on x1 and x2 and getting the y caret, and you're going to be removing these from the regression, okay? And then you're going to be doing the same type of exercise. There are a few problems with non-nesting, okay? Or there are some typos here. So there are a few problems with non-nested testing. You could encounter a situation where a clear winner may not emerge, right? So you basically do this F test and both models could be rejected, or neither model could be rejected, right? So if that is the case, then you basically use the adjusted R-square to choose between the models, okay? But if not, then, you know, if let's say you're rejecting both models, then you have to do more work. If we reject the null, we don't really know if the model is correct, right? We don't know what we are leaning towards. So kind of the bottom line here is that if models have different dependent variables, y versus log y, you know, testing is more of a problem. And we can just use this solution of goodness of it, looking at R-square, adjusted R-squares to pick the model that we are going to work with.